vertical slices. No, I'm sorry, horizontal slices. Let's do the same problem using vertical slices. Simple. Okay. Let me erase this here, and I'm going to put typical vertical slices. Okay, like I explained before, if you were to take a vertical slice right here, a typical vertical slice right here, then its length is given by the height to the parabola minus the height to the line. You with me, guys? However, if I were to take a typical slice right here, then the length of this slice is the height of this branch of the parabola minus the height of this branch of the parabola. Are you with me, guys? So therefore, what will be a natural boundary point where the formulas for the slices change, guys? Can you see that it's right here? See this point of intersection here? If I drew a vertical line there, at that point of intersection, see that point of intersection? To the left of this dotted line, the formulas are the same for the vertical slices. To the right, the formulas are the same. In other words, the lower curve is the line, the upper curve is the parabola. You mean, guys? Whereas here, the lower curve is the parabola, the upper curve is the parabola. You mean, guys? So therefore, what would be a natural way to attack this problem or solve it? You say to yourself, okay, I'm going to divide this problem into two parts. I'm going to calculate this area here, this area to the left of this dotted line, this area here. And then I'm going to calculate this area to the right of the dotted line, and then add them together. Let's call this area A1. Let's call this area A2. Right? Let's deal with A1 first. Here's a typical slice. What is the area of that typical slice? We call it BA1. You with me, guys? What is the width?
dx.
What is it?
dx.
Dx. So I know I'm going to be integrating with respect to that. So we'll write that in a second, dx. But the most important is what is the height of this slice. So if I give you this position x here, what is the height? The height is the y coordinate of this point on this branch minus the y coordinate of this point on this branch. If you give me x, how do I find the y? If you give me x, how do I find the y? Okay? You just take the square root, isn't it? But there are two possible values for y. Y is plus the square root of 2x plus 6. And you could have also y that is minus the square root of 2x plus 6. So let me ask you now. If you give me this value of x, what is the height to this parabola here? The positive square root of 2x plus 6. And then you subtract from that the lower value, which is the minus square root of 2x plus 6. And so therefore, the length of this vertical slice is the square root of 2x plus 6 minus the square root of 2x plus 6. So there'll be two of them. That doesn't surprise us. Because of the symmetry, this parabola has nice symmetry with respect to the x-axis. This guy is equal to this guy. So I might as well just double that to the square root of 2x plus 6. Do you hear me, guys? If you do it correctly, you come out no matter what, dx. Which I write like this, 2 times the square root of 2x plus 6 dx. Am I taking enough time explaining this, guys? I think I am. But at the end of it, and listen, I have experience in this thing. I've taught for 30 years. At the end of it, all what I'm talking about here will amount to zip. if you don't sit down and work the parameters on your own and sweat on the parameters yourselves. It doesn't matter how much time I'm explaining and these pictures and this and that. It really doesn't matter. What you want to do is take this explanation, it fresh in your mind, and you start attacking your parameters yourselves. It's the only way. Okay? I mean, if you find anybody who tells you that there is another way, tell that person to come and talk to me. Because I will not believe it until I see it, I mean, even with all the computers and all that they have now, with making the education simple and fluffy and stuff like that, if the person does not sit down and make their brain work, there's no chance. So that's the element of area for this region here. Now let's see here, I would like to find this piece here. So what I'm going to do, I'm going to add the areas of these vertical slices from here. Let's see where they start. The first slice clearly is going to be here, you mean? And then I want to add over all of them. All of them have that nice simple formula, okay? And the last one clearly is going to be this slice. I cannot go beyond that because my formulas for the slices are going to change. And so therefore the area A1 is adding all those guys. Integration allows you to add infinitely many things. Remember that. That's why we learned it. And let's see. The first slice is positioned right here. You mean? It's this one here. Well, we just said that this point is x equal minus 3. That's the x-intercept of the parabola. Minus 3. And the last slice for this region A1 is right here. And that's just the x-coordinate of the point of the intersection, so it's minus 1. Position minus 1. So here we are taking care of at least of that left part of it. Now let's do this one here. That's going to be easier, at least for some students. This confuses students. The upper branch minus the lower branch and so on, So go back to whatever notes you have on this. Make sure you understand this because you might see it again. Okay? This is straightforward. Let's look at this typical slice. We'll call it the A2 because it's a piece of that area A2. What is the width of the slice? dx. So this tells me I'm going to be doing the integration with respect to x. Integral with respect to x. Okay? dx. What is the height of the slice? This is easy. Because if the typical position of that slice is x, the height is the height to this branch of the parabola minus the height to the line. You with me, guys? So if I give you x, what is this and what is that? Well, we already calculated the heights to the parabola. There is the plus to the square root and minus the square root. Well, we want the height of 1. Just going up, okay? So therefore, the length of that slice is the height to the parabola. When you give me x, this is the y on that parabola, minus the height on the line. And this is the place where students make mistakes. Can we see the plus 1 now? Because it's minus this quantity, you know, guys? So either put parentheses or do the algebra correctly. Minus x minus minus 1, so it gives you that. Times dx. So what is the total area A2? Well, you have to add all of those. So my first slice is here, and I'm going to add. So my first slice is when x is equal to minus 1, you with me, guys? And then I'm going to add over all these infinitely many slices. The last slice is going to be just this point, and it's going to be positioned right on top of the 5 here. Okay, x is equal to 5 in there. And so therefore I'll be adding these areas from, what did you say, minus 1 to 5. Agreed? So what is the total area? The total area should be this plus this. And I don't have to tell you that if you thought about the problem using horizontal slices, it's much more straightforward. As a matter of fact, the computation is much simpler. One integral, because you didn't have to divide the region into 2 parts to account for the fact that those slices formulas change. So then what I'm going to do is I'm going to use Maple to calculate this. And then